This is video lecture number 2 for chapter 22, and we're going to start hitting table R pretty hard. So if you look at table R, we see we have the functional groups for the organic compounds. We looked at the halides, and today we're going to start looking at alcohols, ethers, and maybe something else. But you have to be able to look at table R and see that when we talk about the class of compounds, the alcohols, we're talking about a functional group, which is the OH. We see a general formula where R represents the rest of the molecule, and here's our functional group, so that if we have a name that has 1, 2, 3 carbons, that would be some form of propane. For an alcohol, an OH replaces an H at the end of the molecule, so it is now called propanol. 1-propanol to say where the OH is located, which carbon. So let's look at our notes for chapter 22 and look for alcohols. An alcohol is a hydroxy group. If you remember, hydroxide is OH minus. Here, in an alcohol, we have an OH group. So they call it a hydroxyl group from hydroxide. The hydroxyl group replaces a hydrogen atom in a hydrocarbon. So here is methane, and now we call it methanol. Sometimes we call it methyl alcohol. Alcohols are completely miscible, which means they are soluble in water because they both exhibit hydrogen bonding, and like dissolves like. So the names of alcohols are based on their alkane name. Here's 4 carbons, that's butane, but now we have a hydroxyl group, so it's called 1-butanol, 2-butanol. We don't have to worry about C or D. So if I have 1 carbon, we know it's methane, but as soon as I put the OH group on the end, the functional group, this is methanol, sometimes called methyl, because of the methyl group, alcohol. This is 2 carbons, ethanol, also known as ethyl alcohol, and ethanol is the alcohol that is found in liquor. The second group we're going to look at are called the ethers. Ethers are organic compounds that contain an oxygen atom bonded between 2 carbon atoms. There's no hydrogen bonding in an ether, and each group is listed alphabetically. So here we have methanol, and if we remove the H and replace it with a methyl group, they call it methyl ether, but since we have 2 methyl groups, we're going to call it dimethyl ether. So we have an oxygen between 2 carbon atoms, So in an ether, we name each alkyl group. So we have a methyl on each side. So this would be dimethyl ether. What would this be called? Remember, we named them alphabetically. So I have a propyl group to the left with 3 carbons. I have an ethyl group to the right. So this is called ethyl propyl ether. And notice how the names are separated out. The third group we're going to look at today are called the amines, organic compounds that contain nitrogen atoms bonded to carbon atoms. Amines are derivatives of ammonia, which is NH3. So usually we will find that at the end of a carbon atom or somewhere on a carbon atom, since it's a derivative of NH3, we will find NH2 somehow. So somehow there's an NH2 attached to the molecule. When we name them, we take the basic name of the molecule, the hydrocarbon that it came from, and just add amine to the end of it. So this came from propane. This is called propanamine. To show that the nitrogen is on the first carbon, we call it 1-propanamine. So this would be called 2-butanamine. So remember, all of this is found in table R. So it's nothing you have to memorize. You just have to be able to find it. So we're going to do one more page. The aldehydes. There is a carbonyl group, which simply means a double bonded oxygen attached to a carbon atom. In an aldehyde, the carbonyl group is attached to the end carbon. So a hydroxyl group is OH. A carbonyl group is a double bonded O. In the aldehydes, we draw the molecule. This came from methane, 1 carbon. We drop the E and call it methanal. Methanal. So if I have 4 carbons with a double bonded O on the end, each carbon still needs 4 bonds. This would be called butane, but butanal. We never have to give it a number because it always has to be on the end carbon. Now, along with that are the ketones. The ketones have a carbon attached to a carbonyl group, which is an oxygen, but it's not on the end. So the carbon that's attached to the carbonyl group, the double bonded O, has to be attached to 2 other carbons. So since that is true, the smallest member of the group has to have 3 carbons because the oxygen cannot be on the end. This is propane. To name a ketone, we drop the E and add none. So this is propanone. Now here you may need to have a number for the double bonded oxygen. So in this case, to show that the double bonded oxygen is on the second carbon, because it could have been on the third, this is called 2, it came from pentane, 2-pentanone. So that's it for today. We got through a good number of the functional groups. So we'll finish this probably tomorrow. Have a great day.